Hello students, now in this video we will discuss about the derivation of the laws of conservation of linear momentum by the third law of motion. So we have to use here the third law of motion and we have to drive the relation. Now to drive the relation we have to consider here a two body system. There is one body A, another body B of the different masses m1 and m2 respectively. So first of all the body A and body B, let they are moving with the velocity u1 in u2 along a straight line, and after at any instant of time t they will be collide to each other and force will be acting by the body A on the body B. Similarly the body B will also be applied the force on the body A in the opposite direction. So here is the force acting on the body A by the body B, that is equal to force 1 2. Similarly here the force acting by the body 1 to the body 2, that is equal to force F2. So these two forces are shown here in the diagram at the time of collision, and after that these bodies are again moving with their final velocities v1 and v2 respectively along a straight line. So this is the consideration, and the mathematical part of this we have to start from here. So now because u1 m1 is m1 and u1, these are the mass and velocity of the first body, m2 and u2, these are the mass and velocity of the second body before collision. So we have to find out the linear momentum of the two body system before collision. Therefore the linear momentum of two body system before collision that is m1 u1 plus m2 u2, means product of mass and velocity, there is momentum for the body 1, similarly for the body 2, and add of these two, that is the linear momentum before collision. Similarly we have to write the linear momentum after collision when the body acquired the velocity v1 and v2. Therefore similarly linear momentum of the system after collision, that is m1 v1 plus m2 v2. So these are the momentum. Similarly from the equation number 1 and number 2 we have to find out the change in momentum in the body 1. Therefore change in linear momentum in body A, that is equal to m1 v1, means we have to subtract here m1 v1 minus m1 u1. Similarly change in linear momentum in body B, that is can be written as m2 v2 minus m2 u2. This is the change in linear momentum for the body A. Similarly the change in momentum in the body B. So these are the change in momentum. So after that we have to use here the Newton's third law. Now we know that according to Newton's third law, that is the force acting on the body A by the body B, that is always equal to force acting by the body A on the body B. So we have to use here according to Newton's third law of motion. So we have to write the statement here. Now according to third law of motion, So F12 force that is equal to F21. So therefore F12 that is equal to F21, but both are acting in opposite direction. So we have to put here negative sign. So force acting on the body 1 by the body 2, it is equal to force acting by the body 1 on the body 2. So this statement we have to use here. Now because in this equation it is written as the change in momentum. Here is the force acting by the body 1 on the body 2. Similarly on the body 1 by the body 2, we have to use here the Newton's third law. Then after that, if such amount of force is acting at the collision for any instant of time t, then we have to find out what will be the impulse on the body A. So impulse, therefore impulse on body A, that is equal to force into time. So force is F12 into time. Similarly impulse on body B can be written as force F21 multiplied by time. So this is the equation, it's a group of the equation number here and 3, and these are equation number 4. So we have to find out the result here from the equation number 3 and equation number 4 here. The impulse, and here is a change in momentum. So it's a theorem of the impulse momentum theorem. The impulse is always equal to the change in momentum. So impulse of the body A, that is equal to change in momentum for the body A. Similarly impulse in the body B, that is equal to change in linear momentum of the body B. We have to write here this statement here. So therefore according to impulse momentum theorem, now according to impulse momentum theorem, according to this, the change in momentum, it is equal to impulse. So the statement is impulse equal to change in momentum P. So for the system, so impulse, therefore we have to write the equation for the body 1. So for body A, impulse, that is F12 into time, this from this equation number 4, that is equal to change in momentum in the body A. So we have to write here m1 v1 minus m1 u1, so it is equation number 5. Similarly for the body B, the impulse for the body B, F12 into time from the equation number 4, that is equal to change in momentum for the body B. So we have to write here m2 v2 minus m2 u2. This is the equation number 6. So impulse equal to change in momentum in equation number 1 for a body A, and here is equation in the 6th, that is equal to impulse equal to the change in momentum. Now since the force F12 equal to F21, so if the force F12 equal to F21 and these are multiplied to each other, so the impulse on the body A, that will be equal to the impulse of the body B, but these are in opposite direction. So here in the equation number 5, this F12t equal to F21, that is into t, means the force into time for the body A, that is equal to force into time for the body B, therefore their right part will also be equal to each other. So we have to write here the equation since F12 into T, that is equal to F21 into T, means impulse for the body A, that is equal to impulse for the body B, therefore the change in momentum will also be equal to each other. Therefore we have to write here M1 V1 minus M2 minus M1 U1, that is equal to M2 V2 minus M2 U2. So change in momentum for the body A equal to change in momentum for the body B. Now we have to write here that is U1 in one direction, the value for U in one, and the value V in the next direction. So we have to write like this. So this is M1 V1, here is M2 V2, M1 U1, we have to write in the next part. So we can write here M1 V1 minus M2 V2, that is equal to M1 U1 minus M2 U2. So when we taking minus common, so we can write the equation, that is M1 V1, because these are equal to each other, because F12 equal to minus F21, so we have to put here minus sign here. We have to put here minus sign, and we multiplied by the minus in the bracket. That minus will be here, will be equal to plus, and then minus minus will be plus. So we can write here plus. It means it is the final momentum, and this is the initial momentum. So from this equation we can write that the initial momentum, this, it is equal to final momentum. So it is final linear momentum, that is equal to final initial momentum. So from that part we can write here for the two body system. So always linear initial momentum for the system is always equal to the final momentum. Therefore initial momentum represented by P, initial momentum, it is always equal to final momentum of the system. So initial momentum is, that is M1 U1 M plus M2 U2, that is always equal to M1 V1 plus M2 V2. So this is the statement of the laws of conservation of linear momentum. In that momentum, the actually momentum is always conserved. Before collision momentum, it is equal to the linear momentum after collision. So the momentum will not be changed. It means the momentum of the system is always constant. So this statement, it shows that when we write here the initial momentum of the two body system equal to the final momentum of the two body system, from this statement we can say that the linear momentum of the system is always conserved. So here is we have to prove here by using the Newton's third law of motion, and this is the derivation part of the law of conservation of linear momentum. I hope that you have to understand that topic, and that is very important topic. Okay, thank you very much.